So here's the deal. After spring break, I am going to teach you how to factor a trinomial. Okay? What does it mean to factor? Okay? Next week. Okay? But today we are going to focus on a GCF. Greatest common factor. In your own words, Preston, what is the greatest common factor?
The factor that is the greatest between two numbers.
Okay, so let's go back to like, if I had 22 plus 55. 11 is our GCF. So if I wanted to factor out our GCF, I could write this as 11 times 2 plus 5.
Wow.
Because if I were to distribute, 11 times 2 is 22, and 11 times 5 is 55. Okay. 22 plus 55 is?
37.
Okay. 2 plus 5 is 7 times 11 is also 77. They mean the same thing, they just look different. Okay. So when I ask you to factor, I'm asking you to write something as a multiplication problem. Nice of you to join us. What'd you have for lunch?
Mara.
Oh, nice. Yeah. Sandwich, soup, salad.
Salad.
All right. So let's look at number 13 here. I'm waiting for you to be quiet. Okay. In number 13, I want to know the biggest term that can be divided out of these two. Not even close with the two.
What?
3 and what else?
2. 3, 2, 1. 3, 1. Oh.
3x can be taken out. Huh? If I divide out 3x, what's left for this guy? 2x. And if I divide 3x out of here, what's left? 1. Okay. You know what I love about factoring? I can always check to see if my answer is correct. If we were to distribute 3x times 2x is 6x squared. 3x times 1 is 3x. We got it. This is the answer that I'm looking for.
Just you know, I did mine.
In a little bit. What did you ask me?
Why do we have to do the 2x plus 1 in parentheses?
So we found the GCF and we divided it out, but we have to write what's left because we want these two to be the exact same thing. Okay, kind of like up here with this, right? Okay, I'm really disappointed in the amount of talking that's happening. I know that we're buzzing with excitement, but we still need to learn math. You missed that excitement.
Oh, thank you.
Did you not know?
Oh, not even.
Oh, okay.
Yeah.
Okay, so now let's look at this one. Let's look at the numbers first. If we're looking at 4 and 20, what's the greatest common factor? Okay.
A number.
And how many y's are in common?
One.
Okay,
There's a number.
so this is y to the fourth, and this is y to the third.
0. Well, they're not in common because it's 3 and
No,
4.
no,
So y to the fourth means this, and y cubed means this. So how many multiplied together are in common?
7.
In common.
Oh.
Okay, so y cubed, yes, y cubed is part of the GCF. Okay. Well, now, if we divide out 4y cubed, what's left here? Y to the first, okay? Minus, if we divide out 4y cubed, what's left here? Nope, just 5. The y cubed over y cubed cancels out. Okay. Okay, so now let's just make sure this works. 4y cubed times y gives us 4y to the fourth. 4y cubed times 5 gives us 20y cubed. Sophia. 3x times 2x is the 6x squared. Looking over you. Okay, let's look at these two terms. Let's look at the coefficients first. 18, 6. 6 can divide into both of them.
Oh, yeah.
Okay. Here I have u to the fourth, so that's u times u times u times u. And here I have u to the first. So just u to the first, yep. Okay, now when we divide out 6u, our first term is going to be 3u cubed. Okay, and here it's going to be, oh my gosh, what are we going to have?
0.
1. And if you want to check your answer, 6u times 3u cubed is 18u to the fourth. 6u times 1 is 6u. How about you try number 16?
This is quiet.
Yes.
It was a bad shot.
Do 7 and 2 have a common factor?
No.
No.
So you would just. So these z is 6. 7 is plus 2. That's why.
Like they trade in, it's like trading syringes. Like you can't do that.
I am totally recording right now, and the recording heard you. Hello. No,
You're recording?
I record every time. On my computer. All right. So like the microphone in here catches what I say and it records what you see. And then I upload it to YouTube and I post it every day. So if you're not here, you can watch the video and get the notes.
I'll watch it at about 29 minutes. We go listen.
Okay, Peyton, what is our GCF?
1,
That's it?
1Z,
Z to the what?
6. That's a weird thing.
So you do not need the 1. So what's left here? I put a little mark in my Z's so you don't confuse my Z's and 2's. Good. So now, what do you notice about this problem? It equals 0. So what we're going to need to do is we're going to need to factor out the GCF and then use our zero product property. I think the mouse should be put away. Okay, so for this stuff right here, what's our GCF? 1K. Left over would be 6K plus 1. Okay. When I divide out K, we get 6K plus 1. Now, this equals 0. All right. So this is when we say, okay, I have a product that equals 0. So I'm going to take each of my factors and set them equal to 0. So we have K equals 0. And we have 6K is negative 1. Okay, is negative 1. What about number 20? Okay, the GCF for number 20. Ooh, 7? 7n to the first. Okay, so if we divide out 7n to the first out of each of these, then we're left with 5 minus 7n.
Yes.
Regular 5. And remember, if you're unsure, if your GCF, if you did it right, then you can always distribute and make sure you get back to the original. Okay. Well, now that we have that equals 0, we can say, all right, 7n equals 0. 5 minus 7n. What does n equal here? Over here, negative 7n equals negative 5, right?
Yeah, but you still need to get negative 7 and the other side. Besides negative 7.
Oh, wait, could you?
You know it.
Oh, you did.
Well, I don't need to.
Oh, I thought you said I know that.
Wait, is she gonna like send us a picture? Or, like, she better.
I'm
She
sure.
better, yeah.
Or her husband will have to, because Mr. was not very
What's her
good
husband's
at. It's not Ruba. So the baby's last name is not gonna be Ruba.
Wait, but what were Mr.'s not gonna work?
She's not very good at sending messages from her phone. Or having her phone in general.
Or send an email.
Okay, so